To draw out a circuit, we often use some simple elements to represent the components of a circle. So for example, a single cell is represented with a short line and a long line. The short line representing the negative terminal, the longer one representing the positive terminal. Two cells in series are represented like this. Two cells in parallel would be represented in this fashion with the negative terminals joined and the positive terminals joined and then connected to the rest of the circuit. A switch is represented by a break in the line. A light bulb would be represented by a little loop which represents the filament, and we surround that with a circle to represent the light bulb, and then the fuse is represented by a squiggly line with a dot at either end going into the circuit. So let me draw a circuit involving a single cell, a light bulb, a switch, and we could even put a fuse in. And there we have then a simple circuit. So the electrons flow from the negative terminal through the switch when we close it, through the fuse, to the light bulb, to illuminate the light bulb, and back to the positive terminal. So this would represent a lamp, a fuse, a switch, and a cell all in series. Let's now consider two batteries in series, or two cells in series, and two lamps in parallel. So we would have our two cells in series, and then we can have the terminal going here. So there's a wire. Then we put a lamp here, a second lamp then, and then we take a wire from the negative terminal and bring it across, put in a switch, and connect the wires here and here. Now it doesn't really matter where you put the different elements in the circuit, because of course the electrons will take the easiest route, and the easiest route will involve going from here through the switch and then through either lamp and back again to the positive terminal. So when we have two cells in series, we actually have roughly 3 volts, and both of these lights will be quite bright. If we now go to two cells in series with two lamps in series, we can draw it in this fashion here. Again, a switch. And again, it doesn't matter where we locate the lamps, as long as they're in series with the dry cells. So in this case, the electrons have to go through the switch, through lamp 1, lamp 2, and to the other. In this case, these lamps are now dimmer because the same current flows through both, and the voltage across the two of them combined is still 3 volts. And so across each one is actually 1/2 of that, 1.5 volts. And you can use your voltmeter to actually measure that when you design a circuit. Here we have a circuit that I've drawn involving 2 cells in series and 3 light bulbs, one of which is in series with the other 2, and then we have a switch here and a fuse. Now, the electrons will again flow through here, pass through these 2, and so these 2 will be equally bright. And then all of the electrons have to go through this one. And so this one actually becomes brighter than the other 2 because we have a higher flow of electrons through here than through these 2 here. If we unscrew one of these, then essentially we have electrons flowing through here. And we have got 2 cells, or 2 light bulbs in series. And so they're both equally dim. If we unscrew this one, we have the same situation. The electrons flowing through these 2 light bulbs in series. If we unscrew this one, everything goes out. Because if we take this one out, there's a break in the circuit, and hence these 2 also go out. So this makes for an interesting circuit for students to analyze. Why is it that when you have it like this light is bright and these 2 are barely on? If I unscrew one of these, they become equally bright. If I unscrew this one, again we get equally bright lights. If we unscrew this one, nothing is on when we close the switch. So that's an interesting little circuit for students to try to analyze, and especially for the brighter students, it's something that they can figure out. Here's an example of a circuit in which I have 2 cells in parallel with 2 lamps in parallel and a switch in series. A switch is always put in series with whatever we are trying to turn on or off. And so we can draw it this way. So we would have a connection here and here and here. So we often just put a dot on the corners to indicate that there's a connection. And so the electrons flow from the 2 batteries. The 2 negative terminals are joined together, so they go in this direction through each of the 2 bulbs and back to the positive terminal through there. You could also just simply take a wire directly from here, if you wish, or you can take it from here and go like that instead of doing it this way. It doesn't really matter as long as you just sort of trace the flow of electrons to make sure that they go through the proper connections.